So today's class, we will discuss it what is meant by primary standard solutions and the secondary standard solutions. How can we prepare the primary standard solution? Basically, what are the properties of primary and secondary standard solutions, which we discussed it in today's class. Okay. So last class we discussed what is meant by standard solution. What is meant by standard solution? Anyone? What is standard solution? If any solutions concentrations, if you know, or if you are able to calculate the concentration of a solution, then such a solutions generally we can call it as a standard solutions. So what are the standard solutions generally which we can use it in the titrimetric analysis or volumetric analysis? And what are the, how can we prepare that standard solutions as I discussed in the previous class? In general, if you want to find out it, or if you want to determine the volume of a solution, how much it is utilized for, when we titrate a titrant against titrend. Titrant is nothing but a solution which is present in burette. Titrend is a solution which is present in a conical flask in general. So if you know the concentration of a solution, then it is a standard solution. Or if you are ready to find out the concentration of a solution directly using weight, then only we can call it as a standard solution. So that which we discussed in the previous class. So there are two types of standard solutions, basically primary standard and secondary standard solutions. So what are primary, what are secondary? What is the main characteristics for a primary standard solution, and what about the secondary standard solutions, that which we have to see now. See, standard solution is a solution whose concentration is accurately known is called a standard solution, because simply we have to weigh the substance. From that weight of a substance only we have to find out the concentration by dissolving the substance, known weight of a substance in a either 250 ml or 500 ml or 1 liter distilled water by taking in a standard flask. From that only we have to find out its concentration, that concentration which we can express it in terms of any one of the term like molarity, molality, normality, formality, mole fraction. Anyone which we can use it in general in volumetric or titrometric titrations, we can prefer to estimate the or to express the concentration in terms of either molarity or normality. What is the main difference between molarity and normality is, molarity is nothing but number of moles of a solute present in a 1 liter of the solution is nothing but, that is nothing but indirectly it is a solvent. 1 liter of a solvent, then it is not, we can say that it is a molarity. Units per molarity is moles per liter. Say number of moles of a solute present in a 1 liter of the solvent is nothing but molarity. If we express the same thing, that is number of moles of a solute which is present in 1 kilogram of the solution, then that is nothing but molality. That is the main difference between molarity and molality. We can use it both molarity and molality when we are going to determine the concentration of any unknown solution. From that concentration only we have to find out the amount of the substance present in a given solution, that is nothing but in unknown solution. That's the main principle or main theme which we have to use it in quantitative analysis. So quantity, how much it is present in any solution, given unknown solution, what are the different constituents present in, and how much weight as the constituent which is present in particular solution, that which we have to find out it actually in quantitative analysis. So generally in terms of molarity, if you express it, we have to find out the number of moles of a solute, how many it is present in, and then if we dissolve that solute in a 1 liter or 500 ml, then we can calculate the molarity. If we express the same number of moles of a solute in 1 kilogram of a solvent, then it is molality. And then normality is number of moles of a solute instead of number of moles of, when we have to calculate the number of moles of a solute, simply we can calculate it weight by molecular weight of any particular substance, which gives number of moles of a solute. But for normality, if you want to find out it, normality, we have to find out it the number of moles, but in place of molecular weight, we have to find out it equivalent weight of a substance. What is equivalent weight? Simply we have to divide the molecular weight with its oxidation number or basicity if it is an acid, or how much oxidation or reduction, that is the decrease or increase in the oxidation number if any particular redox reaction takes place. So that is nothing but a oxidation state. Based on oxidation state, we have to find out it the equivalent weight. So number of moles, we can calculate it for normality as weight by equivalent weight, not for molecular weight, as which we have to use it for molarity. So we can express the concentration of a solution in any way we can express it, but the basically we can use it either molarity, normality, or molality, most preferable concentration terms. So whatever may be the term which we can use it for to express the concentration, the only thing is if it is a standard solution, what we have to say is whose molarity or whose concentration has to be known accurately. That is the main thing which we have to remember it for standard solution. This word we can have to observe it entire volumetric analysis, standard solution. So nothing but whose concentration, if you know accurately, then it is a standard solution. So basically there are two types of standard solutions. One is primary standard solution and another one is the secondary standard solution. So what is primary standard solution and what are its properties? And then what is secondary standard solution, that which we have to say now. Okay. So what is primary standard solution? A primary standard compound is a compound from which a standard solution can be prepared by direct weighing of the required compound and dissolving it in a desired volume of water. So what is a primary standard substance and what is secondary? Solution is nothing but when we dissolve the substance in a distilled water, then it turns as a solution. Generally, that is nothing but a primary standard compound if we dissolve in a distilled water, whose concentration, if you are ready to find out it, then it is a primary standard solution. So from primary standard compound, we can simply prepare the standard solution. That is the meaning. So primary standard compound is a compound from which a standard solution can be prepared by direct weighing of the required compound and dissolving it in a desired volume of water. So what are the main characteristics of a primary standard substance? All the substances which are not supposed to use as a primary standard substances. Only few of the substances which we can use it for as a primary standard substance. In general, we can use it sodium carbonate, potassium dichromate, potassium permanganate, oxalic acid, etc. A few of the substance only which we can use it as a primary one, but not the all the substance. So basically primary standard substance, what are the main characteristics as that particular substance, if it possesses, then it can be act as a standard solution. That means it can be prepared from that substance as a standard solution. So what are the main characteristics of primary standard substance? See, first one, it should be easily obtained in the pure state and should not be hygroscopic. So whatever the substance which we can use it as a primary standard substance, that must be available in the nature very easily. That too in the pure state. And it should not be hygroscopic. That means it is not supposed to absorb water which is present in the atmosphere. That is nothing but a hygroscopic. So it should be available in the pure state and it is not supposed to be a hygroscopic substance. That is the first one. Second one is it should not decompose at ordinary temperature. So if you maintain at a room temperature, when we prepare the standard solution from that primary standard substance, if it is decomposed or if it undergoes dissociation, then automatically the compounds, whatever it is present, may be changed, so that at ordinary temperature, the decomposition of the substance, whatever we have used it as a primary, that won't be possible. That is the second condition. That means it should not decompose at a ordinary temperature. Third one, it should have high equivalent mass and molecular mass. It minimizes the error due to weighing. So by weighing of a substance only, we are going to find out its concentration accurately. So whose concentration, if you know accurately, then it is a standard solution, which we know that. So for whatever may be the substance which we can use it as a standard substances, for a primary standard substances, it must have a equivalent mass and molecular mass should be very high. Generally, if whose molecular mass or equivalent mass, if it is very high, then it minimizes in weighing process. Error which has to be minimized when we have to weigh the substance. So for example, if I want to get at a 0.1 molarity of a substance, I want to prepare it as a primary standard substance, whose molarity is 0.1 m. So I have to choose some 0.53 or 0.58 or 1.28, whatever may be the weight of the substance. If whose molarity is more, then weighing the substance, that is the amount of the substance, how much which we have to choose it, is also somewhat more compared to the substance whose molecular mass or equivalent mass is very less. Corresponding only we have to use it the substance weight to find out the molarity or concentration in general. So based on that only we have to choose the weight of the substance, whether we are going to be dissolve the substance in 500 ml or 250 ml or 1000 ml. In general, we have to calculate the concentration with respect to 1 liter only, because as per the definition of molarity, a number of moles of a solute present in a 1 liter of the solution, so that we have to prepare that in a 1 liter, we have to convert into a 1 liter solution. Even though we prepared using a 250 ml standard glass, volume of the solution, how can we calculate it? Means 250 by 1000, which automatically it converts for a 1 liter solution. So in general, if a primary standard substance molecular mass or molecular weight or equivalent mass, if it is very high, when we have to weigh the substance to find out its concentration, then errors in the weighing of a substance, it has to minimize maximum, because of as the weight is very high, molecular mass or a equivalent mass is very high. So that in general, we have to use it a substance that is nothing but whose molecular mass or equivalent mass is very high, that generally which we can use it as a primary standard substance. That is another important property for primary standard substance. Next, the substance should be soluble in water or in the given solvent. So most of the cases, whatever the experiments which we have to perform in the laboratory, whether the estimation of sodium carbonate or estimation of sodium bicarbonate or estimation of both carbonate and bicarbonate, or estimation of dichromate or ferrous, copper, magnesium, whatever may be the substance, if you want to find out it. In general, maximum of primary standard substances, they are readily soluble in water. In general, if it is not able to soluble in water, simply we should add 1 drop of concentrated sulfuric acid first, then add distilled water, it automatically will be soluble. So that is one more condition for primary standard substances. It is readily soluble in general in water. If it is not water, whatever the solvent which we have to use it in that particular experiment, that must be soluble in the given solvent also. Instead of water, we can use it HCl or ammonia to some experiments. But for our laboratory or in the degree practical, we are not supposed to use any other solvent. Generally, we have to dissolve the substance, primary standard substance, in distilled water only. That is for in general in the research, which we can dissolve the substance, primary standard substance, in another solvents like hydrogen fluoride, ammonia, liquid ammonia, and HCl also, which we can use it, but not in our laboratories. Generally, we can use it that which we have to dissolve that substance in a distilled water only. That is the fourth required condition from very primary standard solutions. Then next, its composition should not change when stored or during weighing. This is the main important thing. So it is the same point which we discussed in the first. That means generally it is not supposed to be a hygroscopic. That means it's not supposed to absorb the water, whatever it is present in moisture present in the atmosphere. When it absorbs the water, automatically its weight changes as water molecule which is includes. So that another important condition is a composition of the substance. When the composition changes, generally, if it absorbs the water or oxygen, if it adds or oxidation takes place, or if it is removed the oxygen, or generally, if it removes the water from itself, if it is having any specific properties, like easily oxidation or easily reduction or hygroscopic, such a type of properties as the substance, if it doesn't have, then the composition of the substance won't be changed. When it is possible means when it is having such a properties by absorption of water or removal of oxygen, that is nothing but simply oxidation. If it is having such a properties, then composition automatically changes. Once its composition changes, then automatically concentration. That means when we have to weight the substance. So for example, if I have weight 0.53 grams of sodium carbonate first, I have weighed the substance 0.53 grams, and then I have to transfer that substance into a standard flask using a funnel. Before transferring itself, if I kept the weighed substance in the table or in the laboratory, if it is ready to absorb the moisture, that is water which is present in the atmosphere, then automatically molecular mass of the sodium carbonate, how much I have weighed, it changes. So, if during weight, if it doesn't have any changes, even though if I store the substance for a few minutes or few hours, it is not supposed to change its composition. That is most important property as a primary standard substance, which must has to consist of. Then only it is possible to use it as a primary standard substance. Generally, what are the substance which we can use it as a primary standards are sodium carbonate, sodium oxalate, potassium dichromate, potassium ferrocyanide, sodium chloride, magnesium sulfate, and pure metals also. Some of the metals also which we can use it as a primary standard substance. Out of these, sodium carbonate, which we can use it in the estimation of sodium of carbonate using HCl, that is nothing but weak acid versus strong base titration, and the sodium oxalate, oxalic acid, which we have to use it to estimate ferrous in general. So we have to use it a salt of oxalic acid as a standard solution, that is nothing but sodium salt of oxalic acid. And next one is potassium dichromate, which we have to use it to estimate ferrous or ferric, even nickel also we can, magnesium also we can estimate it. Potassium ferrocyanide generally, which we are not using in our laboratories. Sodium chloride, which we can use it. Magnesium sulfide, also which we can use it to estimate magnesium using EDTA as a titrant. So out of these standard solutions, sodium carbonate, sodium oxalate, potassium dichromate, and magnesium sulfate, which we can use it in our practicals. That means in the lab also we can use that substance as a primary standards. So what are the main properties of a primary standards which we can use it? So we know that we have to prepare the solution using a primary standard substance, and whose concentration we have to find out it accurately. So once we prepare the primary standard solution, using that primary standard solution, we have to find out the concentration of the another substance, whatever it is used in the titrometric analysis. So some of the substance, instead of a primary standard substance, we can use it as a secondary. That means in absence of primary substance, we can use it as secondary. So what are the secondary substances? In general, that secondary substances are secondary standard substances which can be used as a titrant most of the cases. Maximum we can use it as a titrant. So generally any one of the secondary standard substances which we have to use it as a titrant. See, what are secondary standard substances? Generally, what are the main characteristics or properties of a secondary standard substance? A substance with which a standard solution cannot be prepared by weighing, but the concentration of its solution can be found by titration against a primary standard. So a secondary standard substance is nothing but if we are unable to prepare a standard solution using a secondary standard substances. Then what's the use of secondary standard substance means? Secondary standard substance concentration we can find out it by using a primary standard solution in the titrations or in titrometric analysis or in a volumetric analysis. So we can find the secondary standard substance concentration using a primary standard solutions in volumetric analysis or volumetric titrations. But secondary standard substances which are not used as a primary standard solutions or which are not used for standard solutions preparations. That is the main difference between primary and secondary. Primary standard substance which is used for the preparation of standard solutions. That means whose concentration is accurately identified or whose concentration is accurately can be determined by ourselves. Whoever can how to perform the experiment, that person can readily find out its concentration. But secondary standard substance which is not used for the preparation of standard solution, But whatever the solution which we can prepare from a secondary standard substance, that solution concentration we can find out it from primary standard solution in volumetric or titrometric analysis. That is the main thing. Example for that is potassium manganate, potassium permanganate KMnO4, sodium thiosulfate Na2S2O3, ferrous ammonium sulfate, which is having a formula of FeNH4 twice, SO4 twice, 6H2O, sodium hydroxide, HCl, and EDTA. In your syllabus, KMnO4 potassium permanganate, which we can use it, and the indicator we are not supposed to use in this KMnO4, that is permanganometry reactions or permanganometry titrations, which we can call it as. Potassium permanganates, it itself having a pink color. When we titrate against a solution whose concentration, if you want to find out it, and decolorization takes place when the end point reaches, that is auto indicator, which can act as a KMnO4 in general in that permanganometric titrations. And the sodium thiosulfate, which we can use it for the estimation of copper generally. And ferrous ammonium sulfate, generally, which we can use it as a salt to estimate ferrous. Directly ferrous sulfate solution, which we are unable to use it. Instead of ferrous ammonium sulfate, we have to use it same ferrous sulfate solution as a salt of ferrous ammonium sulfate. Because of ferrous sulfate, directly it can undergo oxidation as ferric sulfate. So that only instead of using ferrous sulfate in the titrations of estimation of ferrous, using a ferrous sulfate, which we can identify using potassium dichromate or potassium permanganate, to which we can perform it. In one reaction, we can use it as a primary standard as oxalic acid. In another reaction, no need to use. Directly, we can titrate against a potassium permanganate. So in that, instead of using ferrous sulfate directly, we have to use it ferrous ammonium sulfate solution as a solution in titrant, that is in the conical flask, because ferrous sulfate easily, if it is exposed to atmosphere, it can undergo oxidation very easily. So it converts as a ferric sulfate. So that to avoid such oxidation reaction for ferrous sulfate, when we have to perform the titrations, instead of ferrous sulfate solution, we have to use it ferrous ammonium sulfate. There's no reaction takes place for ammonium, even though we used ferrous ammonium sulfate in the volumetric analysis. And sodium hydroxide and HCl, which we can use it in the titration, that is estimation of carbonate with HCl, estimation of bicarbonate with HCl. So HCl, which we can use it as a standard, secondary standard substance in the estimation of carbonate and bicarbonate reactions. Sodium hydroxide, if you generally we can use it if you want to find out the concentration of an acids. That is a primary standard solution. If you use it oxalic acid, to estimate the concentration of, that is the amount of the oxalic acid, how much it is present in a substance. If you want to find out it, we have to use it sodium hydroxide. And EDTA, which is a complexing agent or coordinating agent generally, which we can use it to estimate any D block metal element like magnesium, zinc, copper, nickel. If you want to find out it using volumetric titrations, we have to use it EDTA. So EDTA is a secondary standard substance. Next, the composition of such substances keep on changing when stored, and during weighing, solutions of such substances of approximately narrow are prepared and then standardized by titrating against a primary standard solution of known molarity or normality. So when we store the secondary standard substances, generally they can be changed their composition or once whose composition, if it is changed, then automatically its concentration also changes. So that what we have to do is we should titrate the secondary standard solution with the primary standard solution. Using the concentration of a primary standard solution, we have to find out it is the concentration of a secondary standard solution, or we should standardize. Standardize is nothing but finding the concentration of the solution is nothing but standardization of the solution. So we can standardize the secondary solution by using or by titrating against a primary standard solution. Indirectly, primary standard solutions concentration either in terms of molarity or normality, which we know already. Once we know, then only we can say it is a primary standard solution. Otherwise, it's not possible. So using that primary standard solution, we have to standardize the secondary standard solution. Why means? Because when we stored or when we have to weight the secondary standard substance whose weight has to be changed when it is exposed to or when it is stored into some time. So that only we should find out its concentration using a primary standard solution. That is the main difference between primary and secondary standard solution. So what are the main precautions when we are preparing a standard solution? What are the precautions which we have to take on? This is most important thing, because if you avoid or if you had prepared the standard solution as your wish without maintaining any precautions, then the concentration changes. First, primary standard solutions concentration itself first changes. We are using the primary standard solution to find out the concentration of secondary standard solution. From the secondary standard solutions concentration, we are going to estimate the amount of the substance present in a given unknown solution, so that all the values in any particular titrations, it has to be changed because of concentration of a primary standard solution changes. To avoid such errors, whatever we have to expect it, we have to take some precautionary or precautions when we should prepare a standard solution. So if you prepare the standard solution accurately, that means whatever the precautions, if you mean, you have to take it, that if you have maintained, then we can get the concentration of the solution, that is whose concentration must be accurate. Once the concentration of a primary standard solution is accurate, then automatically we can get the concentration of a secondary solutions also accurate value, that is nearby at least. And then from that we are going to find out the weight of the substance. So that is also almost equal value which we can get it. So what are the main precautions which we have to choose or which we have to maintain to prepare the standard solution, that which we have to see? First one, the weight of the substance should be accurate. Nowadays, we are not using simple balances. Actually, if we use simple balances, then we have to find out.
We have at 10 botany class, ma'am.
10, 30 or 10, 10? 10, 30,
10, ma'am. 10, ma'am.
10, 10. So the weight of the substance should be accurate.
No, ma'am. At 10:30, Vijay ma'am class, Vijay ma'am told that after Sidhulur sir class, I will take class.
By 10:30 only, you are ready to join the meeting. Otherwise, it's not open. Understood?
At 10:10, Sidhulur sir class, ma'am.
It's only 10 minutes more, 9 minutes more. I will close it. Wait.
Okay.
Weight of the substance should be accurate, and the substance should be carefully transferred from the weighing bottle to the funnel. So what we have to do is simply first we should weight the substance very accurately. Nowadays, what we have to do is generally we are using a digital weighing machine in the laboratories. Before that, we have used a simple balance. When we are maintaining the balance, we are expecting more and more errors in the weighing of the substance, because we have to maintain up to point after point, we have to maintain 4 digits values using a simple balance. But nowadays, which is not using, simply we are taking the weights or we are weighing the substance in the digital balance. Simply we have to take either filter paper or a weighing bottle. First, we should keep the weighing bottle in the weighing machine. Just read down the value, how much you are going to digitally display in the weighing machine, that we have to note it down. Then what we have to do is, we are not supposed to remove the bottle from the weighing machine. Simply add approximate amount of the substance. For example, when we have to estimate sodium carbonate, we have to find out it, we have to weigh the substance around 0.53 grams. So approximate weight, how much you have to weight it, generally we will give you in the procedure itself. So that much of weight, simply we should add it from the bottle into a weighing machine, weighing bottle, just observe the weight of the weighing bottle along with the substance in the digital weighing machine. Then we have to transfer the substance. Once we get, for example, 3 grams is the weighing bottle weight. If you add 0.53 grams to 3 grams weighing bottle, how much weight which we have to get it? 3.53. That is 0.53 grams only. So if 3.53, if you reach in the digital machine, then immediately we have to stop with adding the substance. And then we have to remove the bottle. That bottle, what we have to do is we should transfer the substance into the standard flask. Generally, how can we transfer means we should use it a funnel. Directly, we are not supposed to transfer into a standard flask. Simply, we should keep the funnel in the standard flask neck, then add the substance in the funnel. And then if any substance, if it is attached on the bottom of a weighing bottle, you are not supposed to throw that. You have to weigh the substance, weighing bottle, empty weighing bottle once again in the weighing machine. Once we transfer that into a funnel, simply what we have to do, you should add 2 to 3 ml of distilled water along the neck of the funnel. Simply whatever the salt which we have transferred into the funnel, that has to be traveled into the standard flask bottom. Shake it well until it dissolves. Now we have to add the remaining volume of a water. That means in any standard flask, we can observe one round mark at the neck of the standard flask. Somewhere we can find it based on the volume of the standard flask. If it is a 250 ml, we can find out its exact neck to the bottom connecting part, we can observe it. If it is a 1 liter, we can observe it at the top. So simply one round mark which we can observe it. If you fill the water up to that mark, then whose volume is equal to 250 ml. If you fill above that mark or below the mark, then its volume of the solution, standard solution, which you prepared is not equal to 250 ml. That is main important. So by funnel, we have to transfer it, then dissolve the substance and then add distilled water slowly. Once it is near to reach the mark, then we have to add drop by drop using a pipette. Then only it is possible to mark. In general, if it is a colorless solution, we have to take the lower part as a mark touch. That touch of mark lower part of a colorless solution, which has to be touched to the mark whatever it is present in the standard flask. If it is a colored solution like potassium dichromate or potassium permanganate and all, we have to take the upper mark as a mark which has to touch with the mark which is present in the standard flask. That which we have to remember. And generally, now we have to close the standard flask with a cap and leave it for a few minutes. At least 5 to 10 minutes you have to leave it. Then only we have to pipette out that solution. Now it is a standard solution whose concentration which we have to find out it is in weight, how much weight we have. So what we have to do, once we transfer the empty bottle which we got it, no, that bottle we have to find out it weight once again, because a few milligrams of the substance may attach with the bottom of the bottle. So once again, we have to keep the empty bottle after transferring the solution on a digital weighing machine. Then weight it. First empty bottle weight and the bottle weight after transferring the substance, if both are equal, then the complete salt which is transferred into the standard flask. Generally, we won't get the exact weight both. After transferring the substance, we can get some amount of the substance which is attached on the bottom of the weighing bottle, so that we can get it some weight. So now what we have to do is amount of the substance, how much you weight, whether it may be sodium carbonate or sodium bicarbonate, that which we have to find out it. So weight of the substance with the bottle, how much you got it, and weight of the bottle after transferring the substance, you have to subtract that. Weight of the bottle with the substance, for example, if you treat it as W1, then weight of the substance, whatever you have to be transferred after, that is W2, then W1 minus W2 will use the value of substance, how much it is used for the preparation of standard solution, whether it may be a sodium carbonate, permanganate, dichromate, whatever it may be. Once you know the weight, weight by molecular weight. Sodium carbonate molecular weight 106, sodium bicarbonate 105. That which we have to find out it. Simply, if you know the molecular formula, then we can find out it is the molecular weight. So weight by molecular weight divided by, you have to calculate the concentration in terms of molarity. So molarity is nothing but number of moles of solute by volume of solution in liters. That is the formula. So number of moles, how can we calculate it? Weight by molecular weight. So how much weight you have got the substance, that you know. Molecular weight of the substance, you know, because if you know the formula, we can find out it the molecular weight. So weight by molecular weight, I got it the number of moles for sodium carbonate, for example. And the volume of the solution in liters only. For example, if I prepare 250 ml, then what I have to do? I have to convert that into a 1 liter. So 250 by 1000, if I have marked it, then it becomes as 1 liter solutions concentration. So weight by molecular weight divided by 250 by 1000. If you have marked it, then we can get it the amount of the substance. How much it is dissolved, that is 0.53, for example, by 106. So that is sodium carbonate by 250 by 1000. If you calculate that value, how much we have to get it, that is nothing but almost 0.01 molarity of sodium carbonate, which we can prepare it. So in that way, we have to prepare it the primary standard solution, and whose concentration accurately we have to prepare it. So that is generally precautions. If you maintain it, we can get the almost 0.01 means 0.009 also we may get it. Instead of 0.01, what we have to get it accurate value, we may get it 0.1, 0.2. That means error is more, because if you are not maintaining the precautions correctly. That is main thing which we have to remember. So based on this primary standard solution, secondary standard solutions, how can we prepare the primary standard solution? And what are the precautions generally which we have to take it? We have to weigh the substance accurately, and transferring the substance from weighing bottle to the conical to the standard flask is, which is very important basically. That is more important. If you maintain all this, then we can get it to the accurate value. So next class, we can discuss it. What are the different types of volumetric titrations are there? Using that volumetric titrations, how can we estimate the amount of substance present in? That is the main theme of it, theory of quantitative analysis. That which we can discuss it in the next class. Okay.